Welcome to the review for Exam 2. So this is based on the questions that you guys told me you wanted me to go over from the review. I've also posted the answers to all of the problems, but these are actually working through a few of the problems. So the first one that I was asked to do was problem number 3, to factor 25x squared minus 4. So this goes back to chapter 5. Now the first thing when you're doing this sort of thing is you should ask, is there a greatest common factor? Because remember, that was the decision tree, the general strategy that I posted. There is no greatest common factor because 25 and 4 have nothing in common. There's only x squared in the first term, not the second term. Well, the next question, remember, is ask how many terms? Well, I have two terms. Since I have two terms, we're only looking to see, is it a difference of squares? Well, it's a difference, clearly, and if you look at it, 25x squared is 5x quantity squared, and 4 is 2 squared. So it is a difference of squares, and with that in mind, it's simply, we can use the difference of squares rule and simply break it up into 5x minus 2 and 5x plus 2. So this whole process, this difference of squares, is valuable and important. The next question is very similar, problem number 4. So number 4, we again ask, is there any greatest common factor? No. I mean, you could hypothetically pull out a -1 or 1. That's not really the point. In this one, also again, we have two terms. And so since there's no greatest common factor and it has two terms, the question is it a difference of squares? Yes. 7 is 40 is squared is 49, and y squared is y squared. So we have 7 minus y and 7 plus y. So this just goes back to the general factoring strategy. Ask yourself, first and foremost, is the greatest common factor. There's not a greatest common factor. Or once you've pulled that out, you're looking for how many terms. So if you want, go back and watch that video again about general factoring strategy and how you can use that. So let's move on to the next problem. So this is one of the word problems from chapter 6 again. So a rock is thrown from the top of a building, and we're given the formula h equals -16t squared minus 6t plus 27, describing the height of the rock, h, in feet, t seconds after the rock is thrown. So h is the height and t is the time, and it tells the units, feet, and so forth. It says how long after the rock is thrown does it hit the ground? Well, let me ask you, what's the height of the rock when it hits the ground? Well, it's 0, since the ground is 0. So that means that h equals 0. Well, if I go back to my equation and plug in h equals 0, I get this. So let me ask you, with this, could you go ahead and solve this equation? How would you solve that? Well, hopefully what you're saying is I can factor that, because that's all we've learned so far is to solve this by factoring. And to solve it, I take -16 times 27, the AC method. Well, -16 times 27 is going to give you -432. So we're looking for two numbers that multiply to -432 but add up to -6. So go ahead and take a moment and kind of try to figure that out. Well, if you did that, the numbers come out to be -24 and 18. And notice, I can double check. The larger number is negative. So when I add them together, and indeed they do multiply together to give me -432. So we can break up that middle term, and now we have 4 terms. We can use factor by grouping. So the first two terms, I can pull out a -8t, and I'm left with 2t plus 3. And the last, I can pull out 9, and then again I have 2t plus 3. So this is how it factors. So I factored it, now what? Well, remember the zero product rule means I set each factor equal to 0 and then solve. So if you got to this point, didn't get to this point in time, want you to pause the video real quick and just finish solving each of those to figure out what t is. All right, so if you did that, hopefully you paused it and then came back. We just can move through it, subtract 9 for the equation on the left, subtract 3 for the equation on the right, and then divide accordingly, and we get t equals negative 9 eighths, sorry, 9 eighths, because the negative 9 divided by negative 8 would be positive. And then on the right, we have t equals negative 3 halves. Now remember, t is what? Oh, it's time. Can we have negative time? Nope, we don't have a flux capacitor, so our final answer is simply it will take 9/8 of a second to hit the ground. Okay, so this really actually already had the equation. Now, problem number 22 was not the case. We had come up with our equation, so we actually did this one. This is actually one that we already went over previously. So let's just go through the things we're looking for. We're looking for length and width, because it asks for what the dimensions are. So what are some other pieces of information that I'm given? Well, we're given that length is 8 inches less than twice the width. So that means length equals 2w minus 8. Well, we're also given that the area is equal to 90. This is a rectangle, so how do you find the area of a rectangle? Well, it's length times width. Wait a second, I have L and I have W. If I substitute in, and I know area, so I substitute in for area, I take this, substitute in for L, and then I get this equation. Now, how would you solve that equation? We have to multiply it all the way out, set it equal to 0, factor it, and so forth. So this just goes back to 6.7, how to solve it. So we multiply that out, subtract 90, and now we're going to factor. So if you just got to this point in time, go ahead and pause the video, finish solving by factoring. If you did do it, let's just keep going. Well, the first thing we can do is, remember, I can pull out a 2. Greatest common factor is always the first thing I want to do. Now, AC, I have a 1 here and a negative 45, so that's product's going to be negative 45. What two numbers multiply to negative 45? Well, you can go through that process, you end up with W minus 9 or W plus 5. So if you do guess and check, AC method, either case you're going to end up here. I just kind of jumped ahead. Now we can set each factor equal to 0. Now notice I didn't set 2 equal to 0 because, well, not really much need. If I set 2 equal to 0, then that's just not going to work out. But the rest of this, I can look at that and I get W is equal to 9 and W is equal to negative 5. Well, remember, W is a dimension, it's a length, or excuse me, a width, so it has to be positive. So it has to be 9 inches. Again, it's inches because that's what we're talking about. But we have to find both length and W. So how would you find length? Well, I can plug it back into the L, and just using some quick computation, we come out with 10 inches. So our dimensions are the length is 10 inches and the width is 9 inches. So all of this goes back to just asking those basic questions. What am I looking for? What do I know? How are they related? And then you can solve after you get into an equation. All right, so number 38, the next question that was asked about is this one. So I want to state using rational exponents. So the first thing you can ask is, how do I write a root as an exponent? Well, as a reminder, a fifth root is to a 1/5 power. And we talked about that in 8.1, 8.2. Now, what do I do with the exponents in this particular situation where I have exponent on the outside and exponent on the inside? Well, we can multiply them. So x to the 4/5. That's it. That's all this problem's asking. So don't let it get too bogged down by thinking it's much more complex. The next one is we want to change this to a radical, which means we're going to get roots going on. Well, first thing, I don't like that negative exponent. How can I get rid of the negative exponent? Well, I can write it as 1 over x minus 2 to a positive 3/4. So remember, we move it to the denominator, it changes to positive. So now we're happy. Now, how are you going to deal with that? Well, remember, I can say, well, that's 3 times 1/4. And 1/4 power, just like the last slide, I told you that 1/5 power is a 5th root, so 1/4 power is a 4th root. And that's it. You're done. So again, it just comes back to what does each root mean as an exponent, and then going back and forth between those. All right, let's jump on to the next problem, problem number 42. So this is simplifying. Well, so notice I have the same base. So what do I do with the exponents when I have the same base and it's division? This is going back to your exponent rules from chapter 5, but now we're just using them with fractional exponents. Well, I'm going to subtract them. So we're going to write the exponents of subtraction. Remember, division means subtraction of exponents. Well, subtracting turns into addition because it's subtracting a negative. And further, I changed 2 into 8/4. I did that so I have a common denominator. Because we don't use mixed numbers as our exponents. So I have to make them improper. And then I have -3 plus 8, which gives me positive 5/4. That's it. That's all you have to do with this problem. All right, the next one, this one. Now this also goes back to chapter 5 and using exponent rules, and because it has multiple exponent rules. My advice is stick to the order of operations. The first thing in order of operations is parentheses. So I would mess with everything inside the parentheses first and don't worry about that negative 1/3 power until after everything in the middle is taken care of. So how could you simplify what's going on in the middle? Well, again, we can do division. So division is going to cause subtraction. So I have the 8 just comes down. I have x to the third minus 3/5. And then I have -1/2 minus 3/2. So that's going to turn into 2 to the third, so 8. Now I did that because that's going to make it easier when I'm dealing with this exponent. I can have x, I need a common denominator, so this is 15 over 5. These have a common denominator, but I'm just going to go ahead and take a moment and just rewrite it as addition to make it more clear to myself. Well, we still have the 2 to the third. Now I get x to the 12/5, because 15 minus 3. And I get y to the 2/2, or 1. Which is what we get in the next part, because now I can actually multiply my exponent in. So -1/2 times 3, -1/3 times 3, and -1/3 times 12/5, -1/3 times 1, which gives you 2 to the -1, x to the -4/5, and y to the -3. We can move everything that has negative exponents down to the denominator, which in this case is everything. And we have our answer, 1 over 2, x to the 4/5, y to the 1/3. So this is just exponent rules being amplified with fraction rules. So the first and foremost thing is go back to your exponent rules. How do they work? How do I distribute things? How do I divide? How do I multiply, etc. All right, let's move on to the next one. Problem 61. Now this is a radical equation, and I have two radicals. So remember, with any radical equation, the first thing we want to do is isolate square root. So we want one of those square roots to be isolated. So I'm going to pick the second one because it's a subtraction, makes it easier to move. So by adding this to the other side, I now have 2x plus 6, that square root is all isolated. So how do I get rid of a square root? I can square both sides. If I square both sides, This side squared, that's really nice. That's 2x plus 6. And this I'm going to rewrite out. Now if I multiply this side out, I get 1. So FOIL or distribution, however you want to call it, it's going to give you this whole thing, because the last one will be squared, this square root times that square root, which just gives you 7 minus 2x. Now we combine like terms. On the right hand side, 1 plus 7 is 8. The negative 2x moves over here. And this square root plus that square root are the same, so I get 2 square root of 7 minus 2x. Now I have a radical hanging around. I have to isolate it in order to get it to finish solving it. So we can move by subtracting 8. 6 minus 8 is negative 2. And 2x plus 2x is 4x. Now, I don't really like this 2, and I can actually get rid of it because I can factor a 2 out of here. Or in other words, I can divide everything by 2, and I get 2x minus 1 is equal to the square root of 7 minus 2x. Now, with that in hand, we can again square both sides. So if you haven't gotten to this point in time, I want you to pause the video and see if you can finish solving from here. Otherwise, let's just go ahead and square it. Well, this left-hand side is 4x squared minus 2x plus 1. And I have 7 minus 2x over here, which if I combine like terms, I get 4x squared minus 4x plus 1. All right, so let's just jump to the next slide because I need more room. So here's the same exact equation. How do I solve it? Well, I have an x squared, which means I have to get it equal to 0 and factor it. Okay? So we can add 2x, which will give you minus 2x, and subtract 7, which is minus 6. Now when I have all this, I got to factor it. Well, again, first thing you should always look for is the greatest common factor. 2. That makes my number smaller and easier to work with. Now I'm going to factor this. There's lots of ways. I'm going to do the AC method. And I'm going to factor by grouping. So I can pull an x out of here. This I can only pull a 1 out. I have 2x minus 3 in both them. And left over is x plus 1. So we end up with 2 times x plus 1 times 2x minus 3 equals 0. Now we can go, now how do we solve it? Well, it's zero product rule, so we set each of them equal to 0. This one, yeah, that's never happening, so we're going to throw that out. These two I can finish solving. Specifically, I get x equals negative 1. That's a typo. And 2x minus 3. So I get x equals negative 1 or x equals 3/2. But we're not done. What are we forgetting to do? We need to check our answer. So checking it, we got 2 values to check. Let's start with x negative 1. So plug it in, and we multiply it out. We add things together. Notice the negative times negative is positive. Add those together and I get negative 4, and over here is 9, so square root of negative 4 is, well, 2, and square root of 9 is 3. 1 minus 3, oh, that's a problem. That's negative 1, which is not 1, so we don't like that one. What about the other side? 3/2. All right, plug it in. 2 times 3. The nice part is these are both 2's, so they make it just each of those fractions now become 3's. 3 plus 6 is going to give me 9, and 7 minus 3 is 4. Again, the same square root, so I get 3 minus 2 is equal to 1, and sure enough, 1 is equal to 1. So our only solution is x equals 3/2. We have to completely ignore the x equals negative 1. So remember to check your radicals. Vital, and you're expected to do so. Now, our final 2 questions are both word problems, the last couple of word problems. So 65 is asking me to cut down a tree, and I want to know the safest point to drop it is in the direction of my truck. So do I have enough feet that it's going to miss my truck, or is it going to land on my truck and crush it? Well, I got all this stuff. I have the base of the tree to my truck. I have how tall I am, how long my shadow is, the length of the tree shadow. Whoa, how do we deal with all that? Well, one of the things that's kind of important to know is that shadows and heights are proportional. So at a given time of day, so let's say 1 in the afternoon, how tall you are to your shadow is going to be the same as how tall someone else is to their shadow, a building to its shadow, etc. So can we write a proportion based on height of objects and feet? Well, let's first let x be the height of the tree. Well, one of the ratios I have is x, it's the height of the tree over 37. If x is the height of the tree and over 37, what would be the other side of this based on the information we have? Well, it's going to be 6 over 3.5. Multiply that out. We can do cross master. We can multiply least common denominator, etc. We get 3x equals 6 times 7, which is 222. So x equals 222 over 3.5. But if you start trying to divide that, you don't get a pretty number. The fraction is really horrible. I mean, the decimal is nasty, horrible. So I can actually rewrite it as 44 over 7. I did that because I looked at this bottom and said, okay, I can multiply that by 2 to make a nice integer. But if I multiply the bottom by 2, I got to multiply the top by 2. And this, if I turn that to a mixed number, it's going to give me 63 3/7. So sweet, we found the height of the tree. But are we done? No, because remember, this isn't asking for the height of the tree. I'm asking for how much is it going to miss my truck? Well, how far is the tree from my truck? Oh, it's 75 feet. So I can take 75 minus the height of the tree, because if the tree falls down, it's only going to fall its distance. Now can you do that fraction? So go ahead and take a moment and do that subtraction. Well, you should have gotten 11 4/7, and thus the tree will land 11 4/7 feet from my truck. So our actual answer we're looking for is 11 4/7. And as a reminder, this is a math course. You are expected to be exact as possible. If I want you to round, I will tell you to round. Otherwise, be exact and leave it as a fraction. Unless it's a decimal that ends very obviously, but do not round unless I tell you to do so. All right, let's move on to our last problem. The video is getting very long at this point in time. And that is problem 66, very last problem on the review. Now this boat problem is something we've actually kind of done before. We've with airplane problems and so forth. So we can still do this the same as all the others. So think about this for a second. What are you looking for? The rate of the boat. So what's a good variable for rate of the boat? How about B, boat speed? I have a new word I just made up. Now, to collect your information, how about you make a nice little table? So we can do a table with distance, rate, and time. And our first thing, we'll do it with the current. So it's downstream. So what's my distance going downstream? That's 42. What's the rate of my boat? Well, remember, it's not just the boat speed, because the boat speed in still water is B, but the current is helping it, so the current's making it go faster. Therefore, it's B plus 4. And how much time that take? Some number, I don't know. We'll call it T. Now, against the current, I only went 30 miles. What's my rate? It's B minus 4, and again we get T. So remember, distance is equal to rate times time, or in other words, time is equal to distance over rate. So putting that together with the information I have two equations. Time is 42 over b plus 4, and time is equal to 30 over b minus 4. But since these two times are equal, that means the other side of the equations must be equal. Okay, so now let's use those equations. Let's rewrite it. We're here. Now we want to solve this. Okay, so go ahead and, if you didn't get to this point in time, go ahead and pause the video and solve it. Well, we can, again, cross multiply by the least common denominator, etc. And I'll end up with 42 times b minus 4 and 30 times b plus 4, which when you distribute, you get all these numbers. I can go ahead and add 168 to both sides, and I get 288, subtract 30b, I get 12b, divide both sides by 12, b is 24, so my speed of my boat is 24 miles per hour. Now, let me ask you a question. Does that make sense that a boat could be going 24 miles an hour? Sure. Now, we didn't talk about whether that's cool or anything else, and probably doesn't really matter for the point of this problem, but this general idea is how we can apply it. All right, I hope that helps you understand. Good luck. If you have any further questions, please let me know.